where there's going to be a lot less moisture. And so whenever there's less moisture, you're going to obviously have less refraction and magnification.
You don't get to pick the anomalies that seem to agree with your views and ignore the common observations that don't, and still call yourself an honest investigator. That is intellectually dishonest.
So thinking about all this and thinking about what I had just shown you regarding atmospheric lensing, magnification, refraction, all that with regard to cities and objects at a distance on the land, I got to thinking, I wonder how this would work with the sun and moon. So this is what I came up with. I've got my magnifying sheet frame, and I created a little stand to paste the sun on it and keep it the same height over the flat surface of a table. So the sun is always going to be parallel with the surface. And check this out. All right, here's the first test of a sun moving over a flat surface, and with no atmospheric magnification, it does what we might expect it would. It gets smaller as it goes away from us. All right, now let's see what happens when we add in our atmospheric magnification. Again, water and refraction. Water causes magnification and refraction, right? So let's bring the sun back. Oh, check this out. Refraction bends the light downward. It made the sun set on a parallel surface. As it was moving parallel, the same height, the whole way over a flat surface, the refraction caused the sun to set. Not only that, well, let's bring in the beginning of that little test, and we see that it maintained pretty much the same size, too. Pretty close. And of course, that's because as it's moving away, the magnification is still taking place. And so even though the sun's further away than it was in the beginning of the test, the magnification basically preserved the same size, and the refraction made it set. Of course, again, depending on how much moisture is in the air, we could see that the sun doesn't appear to change in size at all as it goes down. We could see sometimes perhaps that it looks like it's getting bigger when it goes down. You ever see like a really big sunset or moonrise, moonset, where one of them looks really large on the horizon? Well, that could be because there's lots of moisture in the air causing that effect. Or when there's less moisture in the air, obviously you won't have as much magnification taking place, and so it looks smaller as it goes away. So it's all relative to the amount of moisture that's in the air. Now, I'm just going to put forward a crazy idea for you to think about. And that is, if Rob Skiba could figure this out, I'm just going to go out on a limb here. I think it's quite possible that the creator of the cosmos could have figured out the same thing and engineered our beautiful sunsets, thanks to all of that water he placed in our atmosphere. Just something to think about.